Alright, ladies and gentlemen, here we are with a continuation of the notes. So I'm going to start with section 5.3 in this video. In section 5.3, we're basically adding and subtracting rational expressions with like denominators. So if you go back to the basics and let's add something like 2 over 5 plus 1 over 5. Because they both have the same denominator, we just need to focus on the numerator. So in this case, 3 over 5 would be our final answer. So that can only happen, and I can only focus on that because both denominators are the same. Okay, so I can focus on the fact that 2 plus 1 is equal to 3. Okay? Alright, so let's look at example 1. In example 1, well, here we go. They start off with 1/8 plus 3 over 8, and that equals 4 over 8, which reduces to 1/2. And that is what they want. It does not change. In example B of this section, they have 5x over 2x minus 1. They have this added to 3 over 2x minus 1. And once again, I have a common denominator, so then I just focus on adding the numerator. So in that case, this is simply 5x plus 3, and there's nothing else you can do. For section C, or example C, here I have x squared over x minus 4 minus, and here's the thing. They don't put a bracket around this, but I want you to. I want you to put a bracket around the second fraction, which is in this case x plus 12 over x minus 4. And the reason I ask you to put a bracket there, some teachers will tell you put a parentheses if you want to use a parentheses that actually, in the flow of things, might actually be more reasonable. What happens is this negative has to affect here and again here, because you're multiplying the value of -1, which technically is in front of this being multiplied. So it affects both sides. So this becomes a negative, that becomes a negative. Alright, and so our new expression, if I were to eliminate the parentheses now, would be x squared minus x minus 12 over x minus 4. Again, we have a common denominator, so we don't really worry about that. We just worry about this top part. Since that negative is going to float in here, make that a negative. So now we have a big old negative here, and it changes that positive to a negative as well, eliminating the positive completely. We now have minus x minus 12. So what you have to ask yourself is, now can I factor that? Can I factor this numerator? And so in this case, we have again the x minus 4 in the denominator, and if I were to factor this, I bet you that this is an x minus 4 times an x plus 3, because it has to be a plus minus, because that's a negative, right? And that technically this will cancel, leaving you x plus 3 as a final answer. Alright, and so in that case, that's all you need to do. So in the case of an LCD, so I'm going to sort of blend two of the questions together. I'm actually going to use examples 2 and 3 in example. Do I really want to do that? Let me see. Let me think this through first. No, we're going to do this a long way. So I'll do example 2 first by itself. So they want you to find the LCD. And then they're going to give you basically something to the effect of 1 over x cubed y and 5 over 16xy squared z. And so the idea here is, with finding the lowest common denominator, is we want to find the largest number that both can be divided into evenly. So we begin with the 16 as being our largest number. I'm just focusing on the LCD. Notice there's no operation to be done here, okay? Next thing I'm going to look at is the variables. I need to look for the largest exponents. So in this case, x squared, my bad, x cubed, y squared, and the z, there's only one z. That's your LCD. So again, the largest number and the largest exponent value respectively. This is a 1, this is a 2, that's my biggest one, and that's the only one that exists. Okay? When you look at example 3, it's more of the same, but now they're giving you values such as x squared plus 3 divided by x squared plus 9x plus 20, and then they're giving you 6 over x squared plus 8x plus 16, just as an example. And so the first thing you want to do is you want to factor. So I'm looking at this and I was already thinking this has to be x plus 5, x plus 4 as two factors. And this has to be, in this case, x plus 4 squared, basically, which is x plus 4 times x plus 4. So my LCD has to be the x plus 5 and the x plus 4 squared. You have to remember that x plus 4 squared goes into x plus 4 squared. X plus 4 does go into x plus 4 squared. And there's only an x plus 5, which you just dropped. So that is your LCD. In the case of example B, they give you x plus 4 over x minus 3, and then 1 over 3 minus x. Do you notice that this is, in essence, a negative differential? So if I were to extract a negative 1 from here, I could express this as x minus 3. So this is really negative 1 in a sense, up on the numerator. So your LCD for this one, technically, is going to be 3 minus x or x minus 3. And that one's a little tricky, but not terribly. Okay, now we look at example 4. In example 4, we have equivalent rational expressions. So in this case, we have the 7 over 5p squared, and we want to make it equivalent to 20p to the 6. So what I want to ask you is 5 times what is going to give you 20, obviously times 4, and p to the second times what will give me p to the 6, so in this case p to the 4, right? So if I multiply 4p to the 4 top and bottom, because remember, whatever you do to the bottom, you must do to the top. And so this final answer up here will be 28p to the 4th power, okay? And it's the same thing with the next equation. In the next equation, they give you w over w plus 5 equal to an unknown value over w squared plus 3w minus 10. So in theory, what's happening here is this bottom piece is being multiplied by w minus 2. See, when I FOIL that, I get this, which means that I have to multiply this top by the same. My final answer here should be w squared minus 2w. In essence, I'm distributing the value. Okay, so that is w squared. I know you guys always tease me sometimes how I write my 2's. There you go. Okay, and now what about when it's unlike? We've been doing like denominators. What about when it's an unlike denominator? Alright, in that case, I'm looking at example 5. In example 5, I have 3 over 7b plus 4 over b squared. Case in point, to make these equivalent values, well, first of all, on this side, I need to multiply by 7. If I'm going to use 7b squared, because I can't reduce it, I have to at least multiply this side by b, top and bottom. Now this works out so that we have 3b over 7b squared plus 28 over 7b squared. And so we combine our numerator values, so 3b plus 28 over 7b squared. Alright, so that's the idea behind that. So you have to build the denominator. It's no different when you subtract. If I'm looking at example 6, we have, in this case, subtract. We have 3t minus 2 over t squared plus 4t minus 12 minus, and again, I still will always recommend you put a parenthesis here for the second fraction. If not, just mentally. And you get 2t plus 12 for this denominator. So what we want to do here is we want to factor as much as possible. So I'm looking at this 4t minus 12, and I am thinking this has to be a t plus 6 t minus 2. And if I factor this part, this is 2 parentheses t plus 6. I would leave everything else alone. And now the question that this beckons is, if my fraction is really 3t minus 2 over t plus 6 times t minus 2, and this is minus 5. So remember, there's a negative here, and again, we're going to build this fraction. So this is 5 over 2 times t plus 6. The question now is, how do I combine this? So my common denominator here should be 2 parentheses t plus 6 times t minus 2. So then what does this side not have? This side does not have the 2 in the denominator, so we'll multiply like that. And this side, notice that I'm here, I'm multiplying by t minus 2. That's going to be hard to read. Let me move it over. Okay, so I'm going to multiply on this side by t minus 2, top and bottom. And now I have a common denominator. So this now becomes 6t minus 4 minus 5t minus 10. I'm going crazy on the negatives. Give me a minute. Hold on. There you go. Alright, so what ends up happening here, this negative infects this side and that side. Terrible use of words. I shouldn't have said infect. 2 parentheses, t plus 6, t minus 2. And so if I distribute that negative, this becomes 6t minus 4 minus 5t plus 10. And all of this over 2 parentheses, t plus 6 and t minus 2. So combining like terms, I end up with 6t minus 5t, which is simply t. This value and this value added together is t plus 6. And all of this over t, 2 times t plus 6 times t minus 2. So the negatives, notice this will cancel with this. And yes, do not leave a 0 up here. There's at least a 1 sitting there. So it's 1 over 2 times t minus 2. Alright? Alright, let's see what else we have here. We're going to look at example 7. Again, remember, you can always replay this video. As far as the steps in the procedure, nothing changes. This is going to be the same process over and over, just a matter of how. So here we have 2 over x plus x over x plus 3 minus, and I'll put this again in parentheses for you to remind you that it always mentally is a good thing to do, because you are going to distribute that negative and all of the signs do change. This is going to give you x squared plus 3x. So, if I look at this, I can consider that the common denominator has to be, in this case, with the LCD has to be x times x plus 3, because technically that's what this is here. This is x times x plus 3. Alright, and so if that is our LCD, the question then becomes, what does this first term not have? What does this first term not have? And what does this first term not have? So if I look at this term first, I have 2 over x, which means I am lacking the x plus 3. So I'll multiply that top and bottom, right? Plus, if I have x over x plus 3, and I have x times x plus 3 as my LCD, then I have to multiply by x top and bottom, right? And lastly, in my next value, I have minus, and again, consider that this is in parentheses, mentally. Right, and here we have, originally we have 3x plus 18 over x times x plus 3, which is the equivalent of x squared plus 3x. So we don't have to do anything to that part. So now we have a common denominator, and now we're going to combine like terms. We're going to distribute. We're going to do a whole bunch of stuff here. We're going to release that negative in there, and so this new sentence becomes 2x plus 6 plus x squared minus 3x minus 18. And all of this is over x times x plus 3. If I consolidate like terms, I end up with x squared minus x minus 12 over x times x plus 3. I look at that top trinomial, and I know for a fact that this has to be an x minus 4 times an x plus 3, and this is over x times x plus 3. So obviously the x plus 3's are going to cancel, and your final answer is right there. So as you can see, this is not terribly difficult. You just have to stop and think about, you know, a few steps here and there. Alright, example 8. Now we're subtracting, unlike denominators, and they give you 6 over w minus a negative 4 over w. I cannot state this enough. It doesn't matter where this negative is. It could be here, it could be here, it could be here. It doesn't matter. The fact is that second fraction is being subtracted. They have the negative down here. I say whatever works for you, dear. So I'm just going to look at this as the entire fraction is negative, which is exactly what it indicates. So if you keep this in mind, what happens when you have two negatives side by side? Well, they become a big old plus. Your final answer? Basically 6 plus 4 over w, which simplifies to 10 over w. Okay, now the last example in this section, which technically I don't think we even got to this part in class because we did so many examples, for example, throughout the examples. So we have x squared over x minus y plus y squared over y minus x. So I'm already thinking there's a negative to be extracted here. So technically, I could extract this negative already. Meaning that if I extract the negative, so we have a negative 1 times this, and I'm pulling out a negative 1 here. In doing so, this becomes a positive, this becomes a negative, so I really have negative 1 times x minus y. Okay, so our common denominator, in reality, since I took the negative, I'm bringing it up here, this gives me x squared minus y squared over x minus y. And I can factor this as x minus y times x plus or y. And you can see that technically these two will cancel and your final answer will be the x plus y, right? Alright, so that is it for section 5.3, and I will be recording for you section 5.4 with complex fractions in the next few minutes.